Very windy. Okay, I have the recording started. So we're capturing this stuff. I almost canceled class today knowing that the wind would be a problem for a lot of people. So if it's a problem for you, if your power goes out or something, uh, I will know that something is happening that's technical in nature on your end because you will disappear from class. Um, and so I can always respect when somebody disappears from class. It's the people that hang around and don't respond to me saying, "Hey, what's up?" That I get a little bit concerned about. People are trying to be here, but they're not really here. But I won't go on with that. So if you're missing class today because of the wind, I got you. We're recording. You can catch up on what we missed, what you missed later. Today, I'm going to try to spend a lot of time practicing stuff, so it's not going to really help people. They're not going to be able to replicate what we did just by watching the video. It'll be a little bit boring for them, but valuable nonetheless. So before I talk about what I want us to do today, let me ask you, do you all have any questions or anything you want to talk about?
It's not necessarily one of the questions I was online on Canvas. I was trying to go through some of the posted let me see, some of the posted links for the videos and the PDFs that you have available for the Zoom recording.
Yeah.
And I wasn't necessarily I was figuring it out more so this morning than I was some of the other days because I was looking at it and I feel like I was kind of getting lost in the writing more so than just understanding what section I was looking at. But I think I started to figure it out. So are these uploaded according to each class that we have, or it's just in bulk? Here's the Zoom recordings that we're gonna have available.
All right. So let me see if I can understand your question. I'm trying to log into Canvas right now.
No problem.
Right.
In terms of a way I could try to reiterate my statement would be, is there are the Zoom meetings uploaded essentially according to the way we've gone through the semester right now, or is it just um, to whatever extent in bulk, just this is what's available for the Zoom
Yeah.
recording?
Yeah. No, good question, Yanni. So I'm sharing my web browser right now. I'm at our class's landing screen.
Mm-hmm.
And if you want to see the video recordings of our class meetings, you go to pages.
Mm-hmm.
Then you got to click up on the view all pages, and then you get the link, this list. Well, this is what I see. Yours will be slightly different, but there'll be a links to course material. You click on that. And so this is the way I have organized it for everybody. So by date, there's a link to the video. So the first column here are videos. The second column are lecture notes. And the link should take you to the recording of that day's class meeting.
Okay.
So in this way, all the meetings are organized. Okay. And all
I think maybe I had gone on to the previous, because it says links for Zoom meetings and Zoom recordings. However, the ones I'm looking at are the ones that were posted from the previous semester, not this one.
Oh.
I clicked on the links to
I see
Zoom
that.
recording
Yeah.
and class meetings.
Yeah. So yeah, that is the last semester. So I just turned that off. So it's not going to be a distraction for people.
Links to course material. Okay, yeah, I found it.
Yeah.
That makes more sense. Thank you. Because when I was on it, I was satisfied in terms of I had information that I was able to go over, but it's like I said, I was getting kind of lost because I wasn't sure what was what, and it was me trying to interpret the information to understand if it was even relevant or not to what I was trying to do in the moment.
Yeah, and the dates are totally off, right? It's last semester, so
yeah,
yeah.
Entirely.
Yeah, sorry for that confusion. Now
Yeah, no
I should
problem.
have removed that confusion. You'll see the lectures from this semester on the dates that they occurred. I don't have a problem with making last semester's lectures available to people if that's helpful, but I'll turn them off for now so they're not a source of confusion. Thanks for bringing that up, Yanni.
Thank you.
Anything else on people's mind?
Yeah. I took a learning target quiz, but then like the app that I used to turn it into a PDF, it was like not working. So can I just like there's like a time frame in between it of like a couple days now. So like can I just like turn that
Yeah,
in?
just turn
All
it
right,
in.
cool. I just don't want
and-
anything I was like suspicious activity or anything.
Okay, just if turn it in and send me an email explaining why it's late. That would be helpful.
Okay.
Um, yeah, and then maybe try a different app that can serve you better. But yeah, an email explanation. That's all I'm looking for right now. You know, if it keeps happening with somebody, then I might start having conversations with them. But yeah, life is crazy right now. I'm full of understanding and compassion. Anything else on people's mind? Okay, so I'm trying to think. Some people have emailed me over the last few days expressing a certain level of emotion in a way that was clear they felt bad for feeling the way they were feeling. That is, they were feeling a level of anxiety in the course right now, and I think a lot of people are sharing that sense of anxiety right now in the class, and I want to tell everybody that that's normal. All right, we're hitting a place in the course that has a higher level of conceptual and computational difficulty, and that causes anxiety in some people, and that's normal. And so I wanted to reassure everybody that if you're feeling unsure about yourself and unsure about what you can achieve in this course, I welcome you to share that with me. Okay. But I also want you to know that it's a natural feeling. And mathematics, I used to like to say that mathematics doesn't come naturally to anybody. And I probably still think that's true. I haven't thought through it that much. But mathematics takes work to master, and it takes work to get better at. And just like if you play a musical instrument, and I include like singing in musical instruments, but if you play a musical instrument, you know you need to practice, and mathematics takes practice too. So I want to ask you a couple questions, and you might feel like you're sticking your neck out by answering them, but just it'll go by quickly. I want you to respond honestly. And I'm going to ask you two questions. The first question is this: how many people at some point in the semester experienced a lecture or a class period where I talked about something new or something relatively new, and you left that lecture feeling like, oh yeah, I got that. I understand that. That makes sense to me. Right. So indicate with a thumbs up or something in the Zoom if you left class one day feeling that way about something. Yeah, great. Great. Thank you. So now my follow-up question is, how many people have had the experience of leaving class feeling like they understood something and then working practice problems or a learning target quiz over what they understood and feeling like, oh man, I don't know what the hell to do. I don't know how to start these problems. Has anybody ever felt that way? Yeah, me too. Me too. I still feel that way a lot of times. I hope you all looked at the number of people who gave a thumbs up to that feeling. If you feel that way, it's very, very common. Okay, so I think I've got my camera on, right? So I'm gonna use my hands. It's very common for there to be there's this distance between being able to look at a problem and being able to start a problem. A lot of times you'll sit down at a problem and you'll look at it and you won't know how to start it. And there's a certain element of risk taking that has to happen for you to start a problem. And today I want to spend some time just on that process of starting a problem. Okay. And what I want us to do is I want us to break into pairs. There's a little nice way to organize group activities called a think, pair, share. And in a think, pair, share, I state a question and then everybody in the class thinks about it for a little bit. And then when we've had enough time to think about it, that's the think part. We do the pair part, and that everybody goes to a partner and shares their thoughts. They exchange their thoughts on the problem. And then the share part is we all come back as a group and we talk about how we approached it. So in the pre-COVID times, I do a think, pair, share with my class, and I'd say, hey, lean over next to somebody close to you in class, like behind you in your row or next to you in the next row, and that's your partner, and share with them. So we don't have rows, right? In a way, we're all equally close to one another, and we're all equally far away from one another. So to do this think, pair, share today, I need us all to pair up. So I want you to take a minute or two to find somebody in class that you know or you've interacted with before in class, and reach out to them through a private chat and arrange for them to be your partner. So I want groups of two. To the extent that you can make groups of two, I want you to make groups of two. When you reach out to somebody and you agree to be partners, I want one of you to post into the chat to everybody the name of the two people in your partnership. And I'm going to write that down. And Cynthia, if you can help write that down too, that'd be great. So let's start that now. Let's take a couple minutes and have people pair up. Okay. So I'll let you go to it. All right, so we've got a first pair here, Eduardo and Cyrus. Oh, maybe the first one was Joseph. Joseph and Nicholas. All right, Marcos, you found somebody? Marcos and Alton, great. Jay and Alejandra. Elizabeth and Giovanni. Gabby and Rihanna. All right, there's still a few people that need to partner up. We'll give them another minute. All right, Niani and Evan. I'll write that down. And all right, I'm gonna all right, so I think we got everybody. The last group is going to be Antonio, Queen, and Stephen. Okay. So I've made breakout rooms for everybody according to your pairs. And as we do an activity today, we'll throw everybody into the breakout rooms and then we'll pull back and we'll go back and forth a bunch. So hopefully we won't get motion sick when we go back and forth. So I'll repeat, this is going to be what I call a think, pair, share activity. I'll give everybody a question to think about. I'll throw you into the breakout rooms shortly afterward. And so you can share with your partner or partners what your thoughts on the question, and then I'll bring you back and we can have a conversation as a class. So I just shared my iPad screen with you. And I wrote down the pairs of as expressed to me in the chat. And so you can look at that and see if I got that right. I just want to reiterate that Antonio, Queen, and Stephen, you're in a group of two. You're three people in a group of two, but that's okay. Sometimes we have an odd number of people. And when we do group stuff, Cynthia and I will pop around maybe a little bit. Hey, Cynthia, is there anything that you want to tell the group before we get started talking about math?
Not that I can think of. Just Halloween on Saturday. Happy early Halloween, everyone.
Yeah, Halloween on Saturday. I'll remind everybody when your drop-in hours are.
12:30 to 1:30 on Friday.
12:30 to 1:30 on Friday. And I'll remind everybody that I'll give you a token for going and talking to Cynthia during your drop-in hours. Or if those don't work for you, you can go to any other peer tutor and have a conversation and you'll get another token. This is another source of anxiety, taking these learning target quizzes and racking up enough successes to earn a course grade, to demonstrate that you're mastering this material through these learning target quizzes. And Cynthia is absolutely positively your best resource for this class outside of me. So go take advantage of talking to her and her understanding of what we're doing in class, right? It's good regardless of me giving you a token for doing it, but I'm going to sweeten the deal by giving you a token for going to talking to her. So 12:30 to 1 on Fridays, right, Cynthia? Yeah. Okay.
Yes.
Great. Okay. So Let's do some math. Let's talk about math. I'm sharing my iPad. So the theme of today is getting started. Okay. How do you start on a problem? That's the hardest part of a problem, is getting started. I had a teacher in graduate school who liked to say that to be successful in math, you need to know where you're starting and you need to know where you want to end up. And the art of mathematics is kind of going from one end to the other. And if you don't know where you're going to end up, that makes things difficult too. But that's like in a word problem and stuff. The stuff we're talking about right now, like calculating derivatives, really, you need to know where you're starting. So I want to spend some time talking about that today. So what I'm going to do is I'm going to give you a function, and I want you to derive it. I want you to think about the question of, how do I differentiate this function? Pardon me for a second. So I'll give you a function, and I want you to think about what's the first step in calculating the derivative of this function. And that's all I want you to do. It's going to be very unsatisfying. We're not going to work all the way through what the derivative is. I just want to talk about the first step, okay? I don't want you to do it. I want you to think about what's the first step. You ready? You ready for this?
Yep.
Giovanni's ready. Okay, I heard somebody else. Cyrus said he's ready. Yanni said he's ready. Elizabeth too. Okay, here we go. So here's the function. So this will just be an example. So I give you this function f of x equals x to the fifth, and I ask you, all right, what's the first step? And I don't want to, I'm gonna answer it for you, right? So I look at that and I think, okay, what's the first step? Power rule.
I think your screen might be frozen. We're still seeing the today practice with problems in the pairs.
All right, so let's see how I can fix that. People agree? Is that what you're seeing? I'm frozen?
Yeah.
Yeah, we
Okay.
see that.
All right, so I just stopped that sharing. Can you see me now waving at you in my video?
Yeah.
Yes.
Okay. So I'm sharing my iPad again. Okay, so we're back. So here's my example problem. I give you x to the fifth, and I ask you, what's the first step? I think about it for a little bit, and I say, the first step is using the power rule. And that's it. Okay, that's all I want you to do. Good? Good. All right. So I'm going to give you a function. And I'm going to ask you, what's the first step to calculate the derivative? And then I'm going to throw you all into your breakout rooms with your pair, your partner. I want you to think about the first step for a second and then talk to your partner about it. And I'm going to pull you back. Okay. So it's going to be pretty quick. You ready?
Yep.
All right, there we go. X squared sine x, that's a function. What's the first step to calculating that derivative? And now go to your rooms. All right, Cynthia, this is going to go pretty quickly, so I don't think you need to go to any rooms for the first couple. What I'm gonna move toward is doing the chain rule. And once I hit the chain rule stuff, you can start popping around. my experience with my 8 o'clock class is that there are some people that like stopped showing up. They stopped responding. So if you see anybody who's not participating, let me know. We'll probably be able to catch them just by all the going back and forth. But just let me know. What I'll do is I'll put them in a waiting room and see if they do anything, or I'll try to poke them. But just keep your eyes open for that.
Okay.
Okay. All right, people should be pulled out of their rooms in 15 seconds. 5 seconds. All right, everybody should be back now. Okay, so I'm just going to go around the horn. Starting this time, I'm going to start with group 1. So Joseph, what did you and Nicholas say your first step is?
We said to separate both of them and then find the derivatives of both.
Okay, so what do you mean by separate?
So that way it's like 2 different functions.
Okay, so separate and differentiate. All right, thanks. How about Cyrus? How about your group? What do you guys say your first step is?
We said that our first step was to use the product rule.
Okay, product rule. Good. I've heard of that. Alton, how about you? What did your group say to do?
We said to use the power rule, kind of like the first problem.
Okay, power rule. I can see why you'd say that. Jay, how about your group?
We said to do the product rule.
Okay. Product rule. Got birds in the background. That's pretty tropical sounding. Right. Giovanni, how about your group? What do you guys say?
We also said to use the product rule.
All right. Good. Gabby?
We were also talking about using the product rule.
All right. I see a pattern. Evan?
Me and Yanni didn't remember the power rule, but we did look at both of them individually, and we came up with, hey, this is something we can easily look up. Is how to take the derivative of 2 terms multiplied together.
Okay.
So we recognize that the derivative of both the terms are 2x and a minus cosine respectively, and we thought we could fairly easily solve that. Just give it a bit more time.
Okay. And I think I'm in the last group. Antonio.
So we didn't get a talk, but I agree that it would be the product rule because it's like a composition function.
Okay. Okay, so I'm just taking notes here about what folks said. So good. All right. Everybody had a thought on how to proceed. Some of the things people said were processes, right? Like Joseph talked about looking at all these pieces and what you could do with them, and Evan had a similar way of presenting the way he and Yanni were thinking about things. Okay. And that's good. But there's always always a first step. And what I want people to see in this problem is that there's an x squared function and there's a sine function. And they're combined with a multiplication. And so that's exactly when you use the product rule. So I want you to be able to recognize that in a situation like this, you're going to use the product rule. Okay. So Joseph, you and your partner, you were moving in that direction. I tried to ask what you meant by separate, but I stopped myself. Okay. Because I hope you were kind of moving in that direction of product rule. Evan, sounds like you and Yanni didn't have the vocabulary to say the product rule, but you were headed in that direction. And yeah, you could look it up, but the product rule is one of those things you need to memorize. You need to be able to see the pattern and know what rule you use, and you'll get there. You'll get there. All right, let's do another example, another problem. I want to do, so is this number 3? Let's do f of x equals cosine of x over x squared plus 1. Okay. So think about it for a second, and I'm going to throw you right into the rooms. And in about a minute, I want you to talk with your teammates, and then I'll bring you back in a couple minutes. Okay. So I'm sending you to your rooms. All right, people are coming back. We're almost all here. 3, 2, 1, and we're all going to be back. All right. All right. So first step, Eduardo, your team.
Me and Tyrese came up with the quotient rule.
All right. I've heard of that. Marcos.
Yeah, we came up with the same thing, the quotient rule.
Okay. Alejandra.
We said the first step would be using the quotient rule.
All right. I see a pattern. Elizabeth.
Giovanni and I said the quotient rule too.
All right. Rihanna.
We also said the quotient rule.
Yanni.
Yeah, we said quotient rule. If it wasn't that, I was just brainstorming. But yeah, quotient rule.
Yeah. But trust your gut sometimes. Queen. How about you? Queen? Did Queen leave? I think so. How about Steven then?
She's we said the quotient rule, and Queen said that she was having like internet problems.
Okay. Cool. Totally understand. And Nicholas.
We said the quotient rule as well.
Okay. Yeah. I mean, it's kind of having gone through this and seeing everybody identify the quotient rule, it's kind of obvious, right? That it's the quotient rule, because you can see that quotient, the notation just screams quotient rule. So, and once you recognize the quotient rule, then you can either do it because you memorize the quotient rule, or you go look up the rule and implement it, right? And the more you practice, the more the deeper into your memory, the rule for the quotient rule is going to be, right? And just so we're on the same page, the derivative of f over g is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And yes, I want you to memorize this. Yes, you'll always be able to find it in a book, but if you need a book in this class right now, that's going to slow you down. And so there's some degree of reflexive knowledge that I want you to acquire in this class. And you can only acquire that through practicing, right? And it's through practice that you'll memorize this formula. So don't feel like you got to have a flashcard and memorize it first and then do problems. Do the freaking problems first. And then the more you do a problem that has to use the quotient rule, the more deeply embedded in your mind it'll be. And that's what's important in this class. All right, let's do another example. First steps. Okay. Think about it. I'll be throwing you into breakout rooms right now. I'll give you a minute to think about it. I'll give you 2 minutes to talk with your classmates about it, your teammates about it, and then I'll pull you back. Okay. Rooms are open. Oh, hey, Queen. Yeah.
Yeah, it's because my internet connection is really unstable, so I keep on like lagging out.
Yeah. Okay. I'm sorry you're having that problem. You can always, watch the video, but I'll throw you back into the room with Antonio and Steven. Okay. All right. If I can figure out how to do it. I think I can do it. Oh, here we go. Room 8. All right. Thanks for letting me know, Queen. Good luck. Cynthia, do you want to pop around rooms or do you want to wait?
I'm fine with whatever.
Okay. Why don't you sit? We'll watch and see how they do on this one. And yeah, maybe on the next one, which will be similar. Maybe the one after that, when I get a trig function, you can just pop quickly through and ask them what they're thinking, and signal to them if they're on the right track or not.
Okay.
But I'm gonna, yeah. All right, everybody's going to rush back in 3 seconds. So let's get ready for them. Make room. Oh. All right. So everybody's back. We're talking this problem. What's the first step? That's the question I want to know. What's the first step that your group agreed you'd take? So Alton, starting with you.
We agreed on that. I think you'd use the power rule for this one, for the first step.
Power rule. All right, Alejandro, how about your group?
We said we would use the chain rule.
Okay, Elizabeth, how about your group?
My group said the chain rule as well.
Okay, Gabby, what about your group?
We said the chain rule too.
Okay, thanks. Evan, how about your group?
Me and Yanni were talking about how we know how to do these problems. We just don't remember the names of what we were looking at. So, like I know how to approach this problem. Like we just basically following the steps of chain rule, but like I don't know the name.
All right. All right, thanks. Stephen, how about you?
We said the chain rule.
Thanks. Joseph?
We said power rule, but I don't think it's that anymore.
The opinions are stacking up in one direction. How about you, Cyrus? What did your group say?
We said to do the chain rule, but considering the kind of theme of first steps, in our opinion, technically the first step would be to use the power rule in the chain rule.
Okay, so that's a great segue into the conversation about this. Is it so? We've separated into two groups. We've separated into the group that says chain rule, and we've separated into a group that says power rule. Okay, so both of those answers are natural. Both of those answers are understandable, but one answer is better than the other, and that answer is the chain rule is better. Because the chain rule indicates that that's the first rule that you have to take or you have to use. Yes, Cyrus, you feel torn, and you're feeling torn for the right reason, because the chain rule takes multiple steps, right? And the first step in using the chain rule is to do the power rule. Okay. But it's important to recognize that you're doing the chain rule because that will help you understand when you're done. So it's just like when we were talking about this problem, once you recognize that you have to do the product rule, then you know how to do the product rule and those little pieces that are part of that process, and make sure you do the whole process. If you looked at this, you wouldn't say my first step is to take the derivative of x squared. I mean, that's only part of the story. The full story is the power rule. In the same way, the full story here is the chain rule. Okay. Is that cool with folks?
Yes.
Is that you look at this and you say, oh, I need to take the chain rule. I need to use the chain rule. And then that sets up your next steps, right? So when I talked about, and now I'm talking to the camera, when I talked about there's always this little gap between the problem you see and the first step, it's that decision about what you're going to do. And by recognizing you got to do the chain rule, that's your first step. And now I'm mixing up my directions in my hands, I'm sorry. But you take the first step and then that helps you, sets you on the arc for the rest of the work. Okay. All right, let's do another one. All right, so my function is the sine of 2x. Okay, same process as last time. I want everybody to think about what their first step would be. Then by the time you're ready to share that, I'll have thrown you into and you have jumped into your breakout room, and then you'll talk to your teammates. I'll give you a little time there and then I'll pull you back. Okay, so here you go. The rooms are open. All right, I think we're all back. All right, so let's do this thing. What is the first step in calculating this derivative? So I'm going to start with J. All right, I'm starting halfway down my list. Jay, what did your team say the first step was?
We said chain rule.
Okay. One for the chain rule. Giovanni, how about your team?
We said chain rule.
Okay, good. How about Rihanna? How about your team?
We also said the chain rule.
Same. All right, Niani, how about your team?
We had started off with going through the product rule, but yeah, I think it would have been the chain rule.
Okay, good. I'll put you down as a chain rule. Steven, how about your group?
We actually said the product rule, but I'm not too sure.
Okay, fair. Nicholas, how about your group?
We said the chain rule as well as everyone else.
Well, not everyone else. I mean,
Most
Steven's
of
group counts, right? Yeah. No, I'm just having fun. Eduardo, how about your group?
We came up with the chain rule.
All right. Marcos, how about you?
Yeah,
Your
we
team.
came up with the product rule, but we later learned that it was actually the chain rule.
Okay. Very good. So initially, there were some groups that looked at this. Well, there are groups that looked at this as the chain rule. Some groups, it looks like, started with the product rule, and then figured out it was the chain rule. And at least one group stuck with the product rule. It's natural for students who are learning the calculus and who haven't taken trig for a long time, or maybe never had much trig, to look at this as a product rule. Or yeah, to look at this as a product rule. But this is a chain rule problem. And so let me just make a couple comments about some facts to orient you and remove any source of confusion about how we work with trig functions. And the source of confusion is natural. And so let me just make sure that we get this out of the way. Sometimes people call these, what do they call these? Just misconceptions. There's some common misconceptions about trig functions. So one misconception is that when somebody sees an expression like this, their attention is drawn to the parentheses. And one of the first associations we have with parentheses in mathematics is a tool that's used for grouping when we're doing algebra. And so it's natural for people to look at the parentheses and then assume that there's a multiplication here. Okay. So I'll use green. They assume that there's a multiplication here, but that's not the case. Okay, this is not a product. So this is a case when parentheses are used and it's not a product. Sometimes textbooks will not use parentheses like this when they use trig functions. And that's even more confusing from my perspective. Right? Sometimes they'll just write sine of 2x like this. And that even suggests more strongly to me that there's a multiplication there. But what I want you all to understand is that trig functions, the way I write them and the way I want you to think about them is they come with parentheses. So when I write the sine function, I write it this way. When I write the cosine function, I write it this way. The tangent function, I write it that way, right? And then the input goes in here. Oops. You know, I mean, it's analogous. to function notation. And the way we use parentheses with function notation. Okay. These parentheses indicate that there's some sort of input right here. And that's what happens with all these trig functions. So think of these parentheses as being part of function notation. And once you do that, you'll understand, it'll click more quickly that we have to use the chain rule. And then I would strongly suggest that if you see trig functions written without parentheses, go put them in to get you back into this mindset that trig functions are like using function notation. So once you recognize that, then you'll know that it's not a product rule, but it's a chain rule. Okay. And in this case, the chain rule is our sine function is the outside function and 2x is the inside function. So definitely a chain rule. Good? People good with this?
Yes.
Okay. Ooh. So what number I'm at? 5 or 6?
6.
Okay. So no, let's not. I'm going to do cosine of 3x. So I'm going to throw you into the breakout rooms, talk in your team. And if you have time, you can take it the next step if you want. So identify the first step, report back. And if you have some time, you can see if you can take it a couple more steps forward. But the rooms are open.
What do you mean by the next step? Do you mean like explaining what the results of applying the first step would be, or
start doing the calculation of the derivative?
Okay.
Yeah. Okay. Good question, Cyrus.
Thank you.
Yeah.
I don't think it put me in.
All right. Ooh. That's probably because you dropped out again, huh?
Yeah.
No problem. Let's see if I can put you in a room. I know I can. I just need to figure out how to do it. Oh, here we go. 2 unassigned. There we go. Okay. There you go. You're welcome. All right, Cynthia, you want to bop through some rooms?
Sure.
Is there a room you want to start with?
I'll just start at the top with number 1.
All right. You're in 1.
Okay.
You okay, Antonio? All right. I think we're all back. All right. So how many groups tried to actually follow through their first step and try to calculate the derivative? Anybody?
Eduardo and I did.
Yeah. Okay. So we'll do that on this problem too. But let's do what we've done. Elizabeth, what was your group's first step? What do you identify as the first step?
We said the chain rule just because it looked very similar to the previous problem, just a different, trigonomic function.
Yeah, perfect. Exactly. I mean, take advantage of patterns and your experience. Great, right on. Gabby, how about your team?
We were also saying that we thought it'd be the chain rule again.
Okay, good. Evan, how about your team?
We also noted the similarity between this problem and one earlier we used the chain rule on, so we were thinking chain rule.
Perfect. Antonio?
We said chain rule.
All right. Good queen. Good way for you to step in there for your teammate. Joseph, how about your team?
We said the chain rule, and from that we got -3.
Oh, hold on.
sine-
Hold
oh,
on. Yeah. Don't
Okay.
give it away yet. All
Okay.
right. Cyrus, how about your team?
We said chain rule.
Okay. Alton?
We also said chain rule.
Great. Alejandra?
We said chain rule.
Okay, good. Yeah, so it looks like everybody saw that this problem looked a lot like the previous one, right? But a different constant and a different trig function. And you learned that if chain rule worked here, it better work here too. Okay. Yeah, this is great. This is what you get from practice. So Joseph started sharing the group's calculation of the derivative. Does any other group want to share what they got? Anybody else get a function for the derivative? Nobody?
We got an answer as well.
Okay. All right. Alejandra did too. All right. So we'll go Joseph, Alton, Alejandra, and then Giovanni. I don't know which group. Oh, yeah. Well, okay. So let's start with you, Joseph, and then we'll move to the next group that can give us something. What do you get? You said -3.
Sine 3x.
Okay. Alton, what did your group get?
We got the same thing.
Okay, same. So I'll do 2 check marks. Alejandra, what did your group get?
We also got the same thing.
Sweet. Anybody else do it? Evan, did I see? Or Eduardo, I saw you give a thumbs up. What did your group get?
We got the same thing.
Okay. Anybody else get anything different? Good. Do you want me to work through it? Giovanni gives a thumbs up to that. Stephen? Okay, Rihanna? All right. Okay, so we've got this function here, cosine of 3 times or 3 cosine of 3x. Okay. So we've got an outside function and an inside function. That is, x goes to 3x first, and then cosine takes it to cosine 3x. So this is the last thing to happen. This is the first thing to happen. The chain rule says you take the derivative of the outside function, and the derivative of cosine x is minus sine x, and you leave the inside of the function alone. And then you multiply by the derivative of that inside function. And so if you think in terms of inside and outside, that's one way that you can go through it. Alternatively, if, well, here, if you look at this function and you want to break it down as a composition, you see the first thing that happens is x goes to 3x. So that's your first function. And your second function in your composition is the cosine function. So the second function is taking y to cosine of y. So if I call this first function a and the second function b, a of x is 3x, and b of y is cosine of y, where we're thinking of y as 2x in the composition chain. So the chain rule says the derivative of a composition is the product of the derivatives. And so the derivative of a is 3. Right? You see that from here. And the derivative of b, the derivative of cosine y is minus sine y. That's something we learned last week. It's a formula that you should memorize eventually, and you'll memorize it through practice. And so a prime times b prime is 3 times negative sine of 2x, plugging in 2x for y. Right? And so that's exactly that. And that's the answer that the folks gave. So two ways to think about the computation of a chain rule. All right, let's do another one. So that was cosine of 3x. So same thing. Here's a function. I want you to differentiate it. I want you to identify the first step. And then if you've got time, you can follow through and see if you can take it all the way through to a derivative. But I'm opening the rooms. I'll pull you back in a couple minutes. Good luck. Did it work, Cynthia, to have a conversation with those two groups?
Yeah. I when I went in, they were both talking back and forth and both basically said they had an answer.
Already, okay. Do you want to go talk to some of the groups?
Yeah, I can go try group 3 this time.
Okay.
Start with them and see how many I get through.
Okay, cool. Hey, Queen, you still having problems?
Yeah.
Yeah. No, don't apologize. I admire your persistence. I'll throw you back in with Stephen and Antonio.
Okay, thank you.
Okay. All right, people will flood back in 2 seconds. All right. People are back. Sorry, I've lost my chat. I don't know where to find it. Oh, well. So, first step, let's go around the groups. Rihanna, your group, what was the first step?
We were first thinking it was the power rule, but we said the chain rule.
All right, you settled on the chain rule. That's what conversation does, right? Good. Nyani, your group.
Yeah, we were looking at how to derive sine x, and I feel like the discussion would have landed on a similar outcome in the chain rule because it seems like there's too many individual processes to be one specific thing.
Okay. All right. Thanks.
Yeah.
Queen, next.
We said chain rule, I believe.
Okay. Thanks. Nicholas?
We said you start with the power rule first, and then you would finish with the chain rule.
Okay. Thanks. Eduardo?
We stick to the chain rule.
Okay. Chain rule. Thanks. Marcos?
We also came up with the chain rule.
All right. Thanks. Jay?
We also said chain rule.
Okay. Another chain rule. And last group, Giovanni.
We said the power rule.
Power rule. Okay. Good. So a bunch of chain rules, a couple power rules. I mean, all of these answers have a degree of what I'd call correctness. The way I want you to see it, though, is I want you to see it as a chain rule. It's a chain rule that will involve the power rule. Okay, so a power rule is the way you start, but it's not giving you that arc of how you're going to complete the problem. So to explain to you what I mean by that is when you look at this, one of the things you have to recognize is what this notation means. And this notation, it's a very specific notation, the way this 2 is used, and it's meant to indicate that you're taking the sine function and squaring it. So for the groups that said the power rule, they're clearly recognizing that this notation is in play, and that's great, right? That's very difficult for students sometimes. And from this point, it's clear you're going to use the power rule as part of the solution. And so if you were to do the power rule alone, you'd get this. And this is why it's important that, to me, that you recognize you have to use the chain rule, because it's only if you recognize you have to use a chain rule that you know there's something else that goes there. If you recognize that you have to use a chain rule, then you know that the derivative of sine has to go there. And so there's a cosine. So I guess I just calculated the derivative for you. It's 2 sine x cosine x. All right. And the chain rule is critical here. All right. Next one. You ready for it? So I want you and your group to look at this and tell me what the first step in calculating the derivative is. And the rooms are now open.
Hey, Dr. Miller, isn't it time for a break soon?
Do you want a break, Elizabeth?
Some of us have to go pee. We drank coffee.
Okay, I'm going to close the breakout rooms, and Cyrus went in. He'll come back. Here he comes. Is he here? Yeah. All right. There has been a demand for a break. So we're going to take a 5-minute break. I thought I could sneak by you all, but good. Thank you, Elizabeth, for self-advocating and advocating for other people that need to pee because they've had lots of coffee and I'm among them. All right. 5 minutes. We'll come back and then we'll work on this problem. All right. All right, we've all had our break. I'm going to make sure you can see my iPad again. So where we were is we've got this function. I'm kicking you into your teams to talk about what's the first step for differentiating this function. All right. Here we go. Rooms are now open. Have at it.
Can I go to room 5 this time?
Sure.
Work my way down some more.
All right. Thanks.
Mm-hmm.
All right. Okay, so we're all back. We've got the function e to the 2x. So, oh, I didn't do my prep here. So, Evan, first step.
I don't remember exactly what the rule was we were using, but
Okay.
there is one fairly specific to E, and I just forgot the name of it.
We'll call it the exponential rule. Okay, just to
That's it. That's the one, I think.
okay. All right, Antonio, how about your team?
I think we were kind of lost, but we were leaning towards. I think someone said chain rule.
Okay, that's a good guess. Joseph, how about your team?
We didn't know what the rule was called, but we thought that the product of whatever rule it's called would just be the same expression or formula. I'm sorry.
Okay, I'll write down the same expression. Cyrus, how about you? Your team?
We came up with the chain rule.
Okay. Alton, how about your team?
I'm not sure, but I think it's the exponential rule. That's what we came up with.
Okay. Alejandra, how about your team?
We said chain rule.
Okay, chain rule. Elizabeth, your team.
We also said the chain rule.
All right. And Gabby, how about your team?
We were also thinking the chain rule.
Okay. All right. So a bunch of chain rules, some exponential rules. So let's walk through this. So what I want you to see when you look at something like this, what I want you to see is I want you to see the chain rule, and I'll if it didn't jump out at you, I'll try to show you how you can make it jump out at you. Okay. Let me ask the class to indicate through Zoom how many people actually went through and calculated the whole derivative. Any teams go through and calculate the derivative?
Eduardo and I did.
Okay. Anybody else? Jay, you're with Gabby? No, you're with Alejandra. So a bunch of people did. Okay, so we'll finish with that. That is, we'll calculate this all the way through. But here you have this function, and what I want, the way I'd like you to see this is that you've got an exponentiation and you've got a 2 to the x. And so something takes the input x and brings it to 2 to the x. And then exponentiation takes that one step further. So there's a 2-step process happening here that I'd like you to be able to see. And like, this is the function a and this is the function b. And so a of x doubles x and b of y exponentiates y. And so a prime of x is 2 and b prime of y is e to the y. Right? This is the only function that is its own derivative. And so you should like this so much that when you see this, you say, hey, I wish this was just e to the x. But it's more than that. There's something more complex in the exponent. So this isn't just e to the x, it's e to the something else. Oh, I got to use the chain rule then, right? It's noticing that this isn't just x up there that says, oh, I've got to use the chain rule. Let me repeat that. This is your favorite derivative formula because the derivative of e to the x is just e to the x. So when you see this, you should get excited. When you see this, you should get excited, but then you notice that the exponent isn't just x. It's something more complicated. And then you'll say, oh, that's okay. I just use a chain rule. So let me copy this stuff to the next page and we'll work this all out. Oop. So f prime of x in this case is the derivative of b composed with a of x. And the chain rule tells us that's just b prime times a prime. And b prime, we calculated up here, is e to the y, and a prime is 2. So we've got 2 e to the y, but up here, y is 2x. And so that's our derivative. Okay. The derivative of e2 to the x is 2 e to the 2x. All right. So there's 2 derivative formulas for exponentials you need to know. This one should be your favorite. Okay, the derivative of e to the x is e to the x. But what if your base is not the number e? What if your base is a to the x? Then it's slightly different. Then the derivative of a to the x is almost a to the x. It's a to the x times the log of a. So if a is e, this formula gives you the same thing as this formula up here. So there's a consistency. But 2 of the groups talked about an exponential rule, and maybe you were thinking about this or thinking about this one, and that would be fair. We don't call it an exponential rule, but that's the derivative of the exponential. It's the formula for the derivative of the exponential.
I wasn't sure if it was that or a logarithmic, but yeah, I knew it was something of that nature. Thank you.
Yeah. So the log does show up, right? So that much is fair. Okay. So what time is it? It's 11:36. Let's do another one. So we just did e to the 2x. Now I want you to do this. 2 to the 3x. All right. So think a little bit about what's the first step to calculating this derivative. And then I think you'll have sufficient time to start actually trying to crank through the calculation of the derivative in your group. Okay. So I'm going to throw you in your groups, and I'll pull you back in a couple minutes. All right. The rooms are open. Do I need to put you someplace, Cynthia?
I have to admit, I don't remember the first step for this type. Oh gosh.
Okay.
I'm drawing a blank.
So
I was thinking taking the logarithm.
Well,
element. Yeah.
Actually, you just use this formula with the chain rule. So the derivative is that, where this comes from differentiating the 2 to the exponential base 2, and that comes from the chain rule.
Okay.
Does that make sense?
Yeah.
So if you wrote this as A composed with B composed with A, where A of X is 3X and B of Y is 2 to the Y, then A prime of X is 3 and B prime of Y is log 2 times 2 to the Y. So that's how that works.
Got it. I don't know why I was drawing a blank now.
It's been a long morning for everybody. It happens.
Nice. And can I go to room 7, please?
Yeah. Okay, here you go.
Thank you.
Yep. All right, everybody's gonna come rushing back in 10 seconds. All right, everybody's back. All right, so let's go through the list quickly. I've written names down. These are people I'm going to call. You tell me what the first step is, and then we can talk about what the derivative is. Okay. How many people in their groups calculated the derivative of f?
Eduardo and I did.
Some. Okay. Okay. So the derivative calculation relies on this stuff. So you got all the tools you need to be able to do it. But let's go down and first rule. So what you look at the problem and you decide the first step is to do what, Stephen?
Our group got like kind of lost, but I think we said it might be the chain rule.
Okay. Might be the chain rule. Nicholas?
We said chain rule as well.
All right. Eduardo?
We use the chain rule.
Okay. Marcos?
Yeah, chain rule.
Cool. Jay?
We said exponential.
All right. Giovanni?
We said chain rule.
All right. Rihanna?
We also said chain rule.
Niani?
Yeah, we got to the chain rule also.
Got the chain rule?
Yeah,
All right. So
took a process though.
it takes a process, and sometimes, you know, your idea doesn't come first. Sometimes you got to chew on it, and chewing is great.
Mm-hmm.
So the way I want you all to see this is I want you to see this as a chain rule problem. Yes, it's going to use one of these exponential formulas. So seeing it as an exponential rule is very reasonable, but it might prohibit you from getting the right answer. So yeah, chain rule. And the hint that it's a chain rule is this is a basic function to differentiate. And so this differs from this in that the exponent of the function I gave you is more complicated. So that's the suggestion, that if this is a simple formula, this is a more complicated one. And the fact that you're messing with the independent variable is an indication that it's a chain rule problem. So if you do the chain rule correctly, oops, you should get this as the derivative. Okay. Why is that? Well, that's because in this function, your independent variable first gets tripled and then gets exponentiated. So if we call these functions a and b, then a of x is 3x, oops, and b of y is 2 to the y. So a prime is 3, and b prime is log 2 to the y, because of the formula that's on the previous page. So the chain rule says the derivative of f is the derivative of this composition. And the chain rule says the derivative of a composition is the product of the derivatives. And so we have the natural log of 2 times 2 to the y times 3. And here in our work up here, y is really 3x because of this process. And so that's the formula for our derivative. And then we just reorganize a little bit and get that. Okay. If all else fails when you're trying to do a problem where you can recognize you have to do a chain rule, if all else fails, write that function as a composition and then use the chain rule to help you figure out what to do next. Sometimes just knowing how to apply a rule lets you apply it without thinking too much and let the math lead your work. And sometimes you just got to let that happen. All right. We don't have time for any more examples. There's one more thing that I want to say. is today we spent time trying to overcome a natural reluctance or a natural fear in taking a first step in a problem, looking at a problem and saying, I don't know what to do. And I hope I've shown you that you have an instinct for what to do in a lot of these calculations, and you should trust your instinct. But once you follow through on your instinct, you end up in a place and you say, well, I don't know if it's right. And I want to encourage you to pull up Desmos or pull up Wolfram Alpha and plot the graphs, because you have enough tools right now to be able to look at two graphs and decide if one of the graphs is the derivative of the other graph. All right. So that's one way you can check your work to see if your instincts were correct. So follow your instinct. You can all do it, but it takes practice. And today you practiced, and we saw at the beginning, right? You saw these patterns and you took advantage of these patterns to understand what to do in the next example. And that's the kind of thing that's going to lead to your success. So keep practicing, keep it up. You'll all do great. It takes risks, but we're all here to support one another, and just try to remember that. Okay. All right. Thanks, everybody. And go Dodgers, right, Yanni?
You know this, the amount of stress that I was dealing with, Professor, I might not have showed up to class anyway. But yeah.
Yeah, well, they won last night, so. Right.
Trust
Okay.
me, my heart is aware.
Yeah. Okay, thanks, everybody. We're going to call it a day. Stay safe.
Thank you, Doctor.
Stay healthy. Yep.
Thank you.
Thank you.
Thank you.
Dr. Miller.
Oh, actually,
Yeah.
Doctor.
Yeah.
I've been meaning to send you an email about the report sheet that you sent me back.
Yeah.
It's not up to date. It says that I only took one learning target quiz when I actually have taken all the way up to, I think, D4, or recently D4.
Okay, send me an email to let me know that there's that discrepancy, and I need to grade a few more learning target quizzes, and then I'll update all the reports so you can see where you sit now. Okay.
Okay. Thank you.
Thanks for letting me know.
All right. Bye.
Bye.